So first of all, let me present myself. I'm Juan José Saenz de la Torre Lasierra, and thank you for inviting us here. I come from a spin-off from the University of Cantabria in the north of Spain, from the Climate Research Group at the university. So we are a spin-off company that has over 10 years of experience in applying machine learning and artificial intelligence to climate and weather modeling. What we like to say in our marketing strategy is that we cover the whole timeline. So we do short-term weather forecasting with weather models that and atmospheric circulation models that you may have heard about, WRF and so on. We also dabble a little bit in seasonal predictions with seasonal forecast offered by CAMS and other services. But what brings us today here is the climate projections. So for the climate projections, we have done both. We have both experience in downscaling, statistical and dynamical downscaling approaches. We provide the climate projections for agricultural impacts for FAO through the Mosaic initiative. And a little while ago, 1 year and a half, we received funding from the C3S, from the climate change service from Copernicus, to develop Climadjust. Climadjust, like Janet told, is a web service where you can apply bias adjustment methods in a simple way through a web service interface. So a little bit of context, a lot of you have already said that bias adjustment is a necessary step for handling climate projections, but we have identified some barriers of access to bias adjustment, and that's why the C3S funded Climadjust. First of all, there is a barrier of access that it's talked about in the climate modeling community, but in other fields, in the side of impacts and other fields, bias adjustment is a method that it's not widely known. This is because there are also several barriers of access. One is the knowledge barrier. I think that Andrea mentioned on the chat that it's not easily accessible for people that are not in the climate modeling. For those of you that work in the side of impacts, you may know this challenge. The other one is that, like you mentioned, like Douglas mentioned in the presentation, there is no one-size-fits-all approach. There is not a single method, and you have to go on a case-by-case basis to analyze whether it's better to use the mean adjustment, bias adjustment method. You have to apply quantile mapping, etc. The good thing, like Douglas mentioned, is that initiatives like Value, that Douglas was head of, already defined a set of validation methods for bias adjustment. And another barrier is not scientific in this case, it's highly technical. It's that if you work, for example, in hydrological impacts, you need to cover wide geographical areas, and that means that can go to cover and bias adjust full river basins and even bigger areas. And this translates that the data sets that you have to handle can go into the terabyte order. That is something that, for example, we faced as a company in the technical development of the interactive atlas of the IPCC. So Climadjust, in short, is the web service. I will do a quick demo just now, but just so you know the big points about the platform, it's that it's easy to use. It has both a graphical interface, a web service that you can go and click on the different parameters that you want to adjust, but it also enables API access. So if you want to use it through Python, notebooks, and so on, you are able to do so. The main point of the platform is that it enables you to access either reanalysis data sets that come from the CDS, from the climate data store from the Copernicus Climate Change Service, Or you can also upload your own private datasets or weather records. And just to give you a gist on how the platform works, I will do a little experiment. So if you go to climadjust.com and you register, you will go into your profile and you will see something like this. And on the left, you have a menu. You can see the input data that it's available, but you can also go to My Experiments. And this is where the bias adjustment process is done. You have two tabs. On the left, you have the My Experiments tab, where you can see some of the experiments that we are running at the moment. This is the trial for so you will see that there is some failed experiments here. But to set up an experiment, it's really simple. You go to create a new experiment and you hit on the create experiment. You have to name your experiment. I will name it like trial. And here you can either enter the public reference input data. These are the data sets that will be used as a reference for doing the bias adjustment. And here you can choose between WIFERI, ERA5 land, and a dataset that has the Iberian Peninsula. These are the datasets that are available for everyone. And as I mentioned, you can upload your own reference input data. These are NetCDF files that gather observations or weather records for specific areas. And in this case, I can choose one of them that we have uploaded, which is on an area in Egypt near Daba. This is a dataset that was provided by a client of us, and it's only visible by us. It's not available for everyone. Then you go and you select the kind of climate projections that you want to work with. For the moment, we enable Eurocordex, CEMIP5, and CEMIP6 data. In this case, I will choose CEMIP5, for example. And then you select the variable that you want to adjust. In this case, for this private dataset, we have only temperature, but you can also apply it for wind, for maximum temperature, mean temperature, minimum temperature, and precipitation. So we go here, we select the variable, and then you can select the area that you want to cover. In this case, the reference dataset that we selected has a small area, but if you select, for example, CEMIP6, it has a ERA5 land, it has a worldwide coverage, so you would be able to select any area in the world that you want. You can either draw a polygon within the domain that you want to select a specific area, or you are able to select the whole domain if you want to run the bias adjustment over the whole area. Then the tool lets you select, in this case, we were talking about the CEMIP5, the different climate change scenarios that you want to work with. You can run on the historical temporal range, or you can run RCP 2.6 or other climate change scenarios. I will choose RCP 4.5 just as an example. And one thing that we put a specific focus on Climadjust is to always work with an ensemble of climate models. So instead of working with singular models, you can run the bias adjustment for the whole ensemble of 73 models that are available on the platform. And here we go to the critical step. Like Douglas mentioned, there is no one-size-fits-all approach. And on Climadjust, we have implemented 6 different bias adjustment methods. It depends a lot on whether you are looking into climate extremes, if you are looking to adjust the mean temperatures, if you are interested in average or a certain quintile. So we decided to implement these 6 methods: IS-ENES-3, empirical quantile mapping, the detrended quantile matching, quintile delta mapping, the parametric quantile mapping, and the generalized parametric quantile mapping. This is mainly the reason why we want to hold a separate session on next Monday to discuss with you specific use cases. But for the moment, I will select the IS-ENES-3, and here you will be able to adjust. Each one of these bias adjustment methods has different parameters, so you have to be able to select how to modify these parameters. In this case, the platform, depending on the variable that you choose, already selects for you the go-to default parameters, but you are able, for example, to change the distribution, if it's a gamma, a Whipple, or a normal distribution, and how to preserve the trend. In this case, we have selected additive, but you can select a mixed, a bounded, or a multiplicative trend preservation method. And another thing that we put a strong focus is in the validation methods. So like Douglas mentioned, the value cost action already defines some validation algorithms and metrics to look. And that is the validation methods that we have implemented in Climadjust. You can select 2 validation levels, the basic one or the advanced one. The advanced one is more complete. The basic one is faster to do, but we always recommend to go to the advanced. And then the final step is how you want to aggregate the data. Either you can have a temporal resolution of daily aggregation, a monthly, or a yearly one. Daily is usually fastest because it's the native way in which Climadjust works. So that means that if you select the temporal resolution in daily, the system does not have to do any aggregation. You also have the option to have the spatial resolution aggregated to use the original resolution in the reference dataset that you used. Or if you want to aggregate over specific areas spatially, you can upload a GeoJSON file that defines these areas. I think this is more for advanced users, so I would recommend to stay with the native. For the moment, we have one restriction on the platform, is that we work only with netcdf files. So once that you go over the experiment and you create here the experiment, here you have a checkup of the experiment that you are about to launch. But what you will get in the end, it's a netcdf file that you will have to manage on your own. So at the moment, this is what Climadjust does. I have one side note, is that Climadjust uses in its background the Climate4R package that Janet mentioned. And we do this, we stay with Climate4R because we come from the University of Cantabria, and the package was founded by the Meteorological and Climate Change Research Group at the University of Cantabria. They do, I think, most of the maintenance of this package. And it's also the methods that we have implemented in Climadjust and that are handled by Climate4R. They are the same that used on the IPCC Interactive Atlas. So we want to always rely on implementing methods that are already trusting and have always a strong validation method and approach behind. So this is a little bit about Climadjust, but just to know that we are making the platform available for all of you at this clinic, at this virtual clinic. But we want to hold a separate question and answers session for 3 users on Monday 18th. The session will be open to everyone. You are always welcome to attend, But we want for you to send us the problem that you are working on, the use case. You can send a little description to the email here, info@climadjust.com, and we will select 3 use cases from all the emails that we receive. We want to select 3 use cases. We will select the 3 use cases by looking at the variability between the use cases. So that means if there is one of you working on climate extremes, another that it's working, for example, on the average trends and so on, we will try to mix these cases up and select 3 that are varied enough so the discussion can be also go to different places in this session. So on the session on Monday 18th, we will focus on the discussion of these 3 use cases. It will be a 1-hour session. We will give 15 minutes each one to discuss. We will welcome questions not only from the person that submitted the use cases, but also from those of you that are attending. And to do this, what you have to do is you sign up at climadjust.com. You make for a free profile. And the free profile that we offer on climadjust.com, it's a little bit limited. So for example, you have no access to API access or to validation. So you have to send us an email to info@climadjust.com saying, okay, I'm working at the clinic, I come from the IS-ENES clinic, this is my use case, what I want to do. We will then go to your user, activate your user for the advanced capabilities of Climadjust, so you have more computing hours and access to API and as well to the validation features. And then we will tell you, okay, we have selected your use case for the session on Monday, that, by the way, will be held at 12 o'clock Central European Summer Time. So if you have any questions or are there any questions on the chat, I will be happy to answer them.